All right, hopefully you did well on quiz 10 in our last lesson. Students in here did very well, so very pleased there. Make sure you do know your terms, though. I had a little bit more trouble on terms than I expected, so be studying those. Next section in your notes, let's talk about absolute value equations. Some review from Algebra 1, which again, for some of you was last year, for some of you, it's been a little while. All right, so solving absolute value equations. Again, an equation is simply an algebraic expression that has an equal sign in it, right? So an absolute value equation would have absolute value and an equal sign in it. Make sense? For instance, maybe something very basic, like the absolute value of x is 3. Now, let me ask you this. The absolute value of what is 3? That's another way you could reword this, right? The absolute value of what number is 3? Well, what could you take the absolute value of and get 3, class?
Negative 3.
Negative 3. Or 3. Either one of these could be x, right? Or you could say x could be either of these, right? If I said the absolute value of x is equal to 7, then that means that x, class, either equals 7 or x equals negative 7, correct? If I said that the absolute value of x minus 3 equals 5, well, then that means that the x minus 3 as an entire quantity could either equal, no, x could be 8, but x minus 3 could either be 5, or x minus 3, the entire quantity, could be negative 5. Now, obviously, then, yes, that means x could either be 8 or x could be negative 2. Right, either an 8 or a negative 2 would give me the 5 or the negative 5. But this is the idea. If you have absolute value, take whatever's inside and set it equal to positive or negative whatever. Take what's inside, set equal to positive, negative, whatever. Take what's inside, set equal to positive or negative, whatever. So the first step in your notes is to isolate the absolute value. Step number 1 is to isolate the absolute value. Get that absolute value by itself. Step number 2, form 2 equations. Form 2 equations in which absolute value equals both positive and negative whatever. Whatever meaning whatever's on the other side, but I'm too lazy to write all of that. Okay, so isolate absolute value and then make 2 equations in which you set it equal to positive and negative whatever happens to be on the other side. And of course, step 3, solve the 2 equations. Solve the 2 equations. Write this example in your notes if you would, please. The absolute value of 3x minus 4 plus 1 equals 3. Again, this premise that you could take whatever's inside absolute value and set it equal to both positive and negative whatever is based on the premise that the absolute value is by itself. Well, we can't assume that here because obviously absolute value is not by itself. So step 1 we said, class, was to isolate the absolute value. That's your keyword. Underline that word isolate. Isolate the absolute value. What would I have to do, Maddie, to isolate the absolute value? All right, subtract the 1, or you could say move it to the other side as a negative 1. At which point the absolute value is now isolated. The absolute value of 3x minus 4, class, equal to 2. Step 2, I said to make how many equations, class? 2. In one of the equations, we're going to take whatever's inside the 3x minus 4, and we're going to set it equal to the positive 2. And then we're also going to take the 3x minus 4 that's inside and set it equal to negative 2. So we're going to make 2 equations. Step number 3, solve, right? We've got 2 little equations, solve them both. In both cases, class, we're going to want to move the negative 4 over as a positive 4. Here to get 3x equals 6, so x equals 2. And in the second instance, when we move the 4 over as a positive, it's going to get us 3x is equal to 2, in which case x is equal to 2/3. And there are our 2 answers. Isolate the absolute value. Make 2 equations. solve them. How many remember doing this in Algebra 1? Okay, some of you do, some of you say, nope, I definitely don't remember this. Might have done it, but nope. All right, so we are going to have to work a little bit harder than perhaps. Write this down if you would. 2 times the absolute value of x plus 1 minus 3 is equal to 7. 2 times the absolute value of x plus 1 minus 3 equals 7. I want you to write yourself a little note here, because sometimes students look at these absolute value bars, they say, ooh, those are a grouping symbol, and they are. They do group this as one quantity, but they're not the same as parentheses. If these were parentheses, class, we would have to distribute. Write this down. Don't distribute, colon, isolate. Don't distribute, isolate. We're not going to multiply the 2 into the x plus 1 to get somehow the absolute value of 2x plus 2. Instead, we're going to isolate the absolute value of x plus 1. We're going to do what the first step says to do. But there's actually 2 different things that have to go for this right here to be isolated. First, class, we've got to get rid of the negative 3, which is less attached. How would I get rid of the negative 3 here, Kendall? Add 3 to both sides, or move it over as a positive 3, right? To get 2 times the absolute value of x plus 1 is equal to 10. Make sure you're doing this with me. But it's still not isolated. First number's gone, but we still have to get rid of the 2. How would I get rid of the 2 here? Abby?
You can divide both by 2.
Good, the 2 is being multiplied. We can't distribute it in, but we will still recognize it's being multiplied, which means we divide. And when we divide by 2, it's gone. And notice now the absolute value is isolated and equal to 5. Once we've done the first step, which this is all step 1, isolate the absolute value. Step number 2, class, is to form 2 equations. What should my first equation be? Brandon?
X plus 1 equals 5.
X plus 1 equals 5. And then for my second equation, Audrey? X plus 1 equals negative 5. In both cases, class, we'll move the 1 over as a negative 1 to get x is equal to 4 and x is equal to negative 6. And there are my 2 answers. It's still a conditional equation, by the way, because there's the condition that x has to be 4 or negative 6 for it to be true. It's not true for anything, and it's not never true. Conditional equation that happens to have 2 specific values of x for it to be true. Questions on this? Yes, ma'am.
What's the title?
Solving absolute value equations. Solving absolute value equations. Brecken's like, ooh, thanks, I'll write that down. She just came in, Brecken. All right, I just started paying attention too. Oh, Brecken. All right. All right, 3 times the absolute value of 4x minus 1 plus 2 equals 8. And ye who just walked in, what's step 1?
Isolate the value.
Isolate the absolute value. So 2 numbers I've got to get rid of.
Positive 2.
And then the,
3.
let's get rid of them in that order. So start by
I'm subtracting 2.
subtracting 2 from both sides to get
3 times 4x minus 1
an absolute value of 4x minus 1.
equals 6.
Good. And then I need to get rid of the
3
by,
divided
because it's being multiplied. So since this is being added, we subtract. Since this is being multiplied, we divide. We're just very contrary like that. Some of you do very well with this. And then what do we need to do next?
absolute value of 4x minus 1 equals 2.
All right, and once we've got it isolated, we realize there's 2 different values that 4x minus 1 could be. I can either replace this whole thing with a 2, because the absolute value of 2 is 2, or the absolute value of negative 2 is 2. So the entire thing inside the absolute value gets set equal to both positive and negative, that. So what are my 2 equations we should write down in Genesis?
4x minus 1 equals 2. 4x minus 1 equals negative 2.
And then we solve. To solve, class, we need to first
Take away the 1.
well, the negative 1 by making it a
Positive.
positive 1 on the other side. Make sure you show that step. Again, so many times we try to do that mentally, and our brain is seeing a negative 1, so we fill in negative 1 even though we know it's a positive. If you write the plus 1, you're not going to screw that up. So I end up with 4x is equal to 3, and 4x is equal to negative 1. So when we divide both sides by 4, we end up with 3/4, and I'm going to slide the negative out front, negative 1/4. Questions on absolute value equations? How many feel like I got this? All right, good. It helps if you remembered from previous years, but even without, I should be pretty good with this. All right, I've got two problems for you to work. 3 times the absolute value of x minus 4 plus 1 is equal to 10. And then also the absolute value of 2x minus 3 minus 4 is equal to 3. And work both of those at your seats. Looks like most of us are about finished. Michael, take the first one. Walk us through.
You have to isolate the thing. So minus 1, put minus 1, and you get 9. And then you divide them both by 3, and you get 3.
So absolute value of x minus 4 equals 3.
Yep. Then you get x minus 4 equals 3, and then x minus 4 equals negative 3. And then you got to add 4 to both of them. And that gives you x equals negative 1, or positive 1, and then x equals 7.
How many positive 1 and positive 7 as your answers? Excellent. On the next one, let's have Audrey walk us through.
You add 4 to both sides, and you get 2x minus 3 equals 7.
Well, I get the absolute value, 2x minus 3 equals 7, so that gives me
2x minus 3 equals 7, and 2x minus 3 equals negative 7. And then you add 3 to both sides. You get 2x equals 10, and 2x equals negative 4. So you divide by 2, you get 5, and negative 2.
And there we go. How many got 5 and negative 2 for your answers on the second? Questions on this?
I got negative 2 and 5.
Same thing. 5 and negative 2, 2 and negative 5. The order isn't so much important here. Yeah, good question. All right. Now there is one little issue, right? Most absolute value equations are going to have 2 answers, but not always. Let me give you an example. If I said that the absolute value of x equals negative 3, we're really saying this. What can you take the absolute value of and get a negative 3? Class? Maddie's just shaking her head. Nothing. You can't take the absolute value of anything and get a negative. Write this in your notes. If you get absolute value equal to a negative, there's no solution. If you have absolute value equal to a negative, there is no solution. Essentially, it's a contradiction. It's never true. There's nothing. Now, you might insert this word, an isolated absolute value equal to a negative. Here's where some students will mess up. They'll see something like this. The absolute value of 2x minus 1 minus 7 is equal to negative 2. And they're like, ooh, I got this. No solution, because see, it equals a negative. But the absolute value isn't isolated yet, is it? What would I have to do to isolate the absolute value, class? Add 7. And suddenly, the isolated absolute value is equal to a positive, and we can make our 2 equations. Does that make sense? There will be other times, for instance, that it might not look like, a negative. Maybe negative 3 times the absolute value of 2x plus 1 is equal to 18. Well, it doesn't look like it's equal to a negative, but as soon as you divide both sides by the negative 3, well, now I've got isolated equal to negative 6. Now it's no solution. So the key is get the absolute value by itself before you make a verdict. Or something like, for instance, write this in your notes, 2 times the absolute value of x minus 5 plus 12 is equal to 4. Go and write that as an example in your notes. What's the first thing we have to do, class? Subtract the 12. And when we do, we get negative 8. And then, of course, we have to divide away the 2. And when I divide away the positive 2, I end up with the absolute value of x minus 5 is equal to... Once you've isolated the absolute value, now we see it's equal to a negative, now no solution. Does that make sense? That way you don't misguess something early, okay? Move that out of the way so people can see. Okay? So if an isolated absolute value is equal to a negative, no solution, it's a contradiction. Easy enough to memorize? But again, always isolate the absolute value first. Don't try to now make two equations. You really can't. It's never going to be true. There's also a case where an absolute value could have only one solution. Write this down. If an absolute value equation has a variable inside and outside the absolute value, if an absolute value equation has a variable inside and outside the absolute value, you may have one solution and an extraneous root. If the absolute value has a variable inside and outside the absolute value, okay, there's a variable inside the absolute value, like we see here, right? There's an x inside the absolute value. But if there's an x outside as well, you may have one solution and you may have what's called an extraneous root. How many remember this term from your Algebra 1 days? Extraneous root. Okay, only a couple of you remember it. We didn't see it often in Algebra 1. You'll see it a lot in Algebra 2. An extraneous root, if you want to get this definition down, is an answer that is gotten by correct work, yet does not check. It's an answer that is gotten by correct work. There's no mistakes in your work. It just doesn't check. It's a lie, a sneaky lie, such as a slick politician might tell. And you have lies that other politicians tell that are not so slick, that everyone knows they're a lie, and you wonder why the politician said it in the first place. But anyway, an extraneous root. Okay, it's a root gotten or an answer gotten by correct work. It just doesn't check. So therefore, let's put this together then. If variable inside and a variable outside, for instance, write this down. Absolute value of 2x minus 3 is equal to 4x. All right, do you see how there's a variable inside the absolute value? But there's also another variable that isn't in absolute value, right? This is what I mean by variable inside and variable outside. If you see that, because it's likely you'll get an extraneous root, you have to check. Okay, normally I'm like, we don't want to check equations. We're too lazy, right? We just trust that we did it right the first time, and we turn out and like Michael, our quiz is perfect, right? Or sometimes maybe not perfect. But anyway, well, with extraneous root possibilities, you better check all the answers. Let's work this together here. I've already done the first step, right? I've isolated the absolute value, so we're going to make two equations. We're going to set this here, class, equal to both positive and negative, whatever. So my first equation, 2x minus 3, class, equals 4x. And we'll say that 2x minus 3 equals negative 4x. Just because there's a variable doesn't change the process, right? We still have a positive and negative, whatever. In this case, it's positive and negative 4x that it's equal to. Now in this case, we have to get rid of the little x, don't we? Here, the little x, class, is the 2x. And to get rid of the 2x, I need to put it over here as a negative 2x to get negative 3 is equal to, careful, positive 2x. Which means, divide both sides by 2, x equals negative 3 halves. There's possible answer number 1. Let's go to our next possible answer. And here, which x is the little x?
-4.
The negative 4. So if we bring that over as a positive 4x to get, I should probably also send the 3 to the other side as a, negative 3, excuse me, to the other side as a positive 3. And when I divide both sides by, I end up getting x is equal to 1/2. There's my other possible answer. I think, and again, I don't work a lot of these on a regular basis. It's kind of specific to Algebra 2, but my memory tells me sometimes both of them check. A lot of the time, only one of them checks. So let's check them both. Let's start with the easy one. I like the 1/2. That just feels easier to me. What is half of 2 class? 1. And 1 minus 3, negative 2. What is the absolute value of negative 2? 2. All right, come over here. What is half of 4? 2. Does 2 equal 2?
Yes.
All right, this one checks. That doesn't necessarily mean this is extraneous. It could still check, but a lot of times the second answer will be extraneous. Let's try this one. I need to multiply by negative 3 halves. And remember, this is a 2 over 1. So the 2's are going to cancel to get negative 3, negative 3. Well, what is negative 3 plus negative 3? And so the absolute value of negative 6, 6. All right, now we need to multiply by negative 3 halves. Again, this is a 4 over 1. 4 and 2 are going to cancel to give me 1 and 2. 2 times negative 3. Does 6 equal negative 6? No. That's the extraneous root. We didn't make a mistake to get it. There was nothing wrong about our work. It just doesn't check. That's extraneous. That's the only solution. Questions on this? This is not something you saw in Algebra 1. So like I said at the beginning of the year, Algebra 2 is a lot of, hey, this is what we did in Algebra 1. Let me show you something a little more than what I showed you before. Look in your textbooks, if you would, at page 66. Page 66. So again, general plan of attack, class. Always first, isolate the absolute value. If you see absolute value in the equation, isolate it. Once you've isolated it, you generally want to try to form 2 equations. Unless you look at the other side and you happen to see a negative. Then you just go straight to no solution. What if you look at the other side and there's a letter over there? You know you're going to have to check because one of your answers could be extraneous. All right? And then if it's just a positive number, then you go about your normal business. I want you to do the odd numbered problems on page 66. Numbers 19 to 27. Not all of the odds, but 19 to 27. The odds. Well, let's see how we do. With some normal ones, some annoying ones. Brecken's like he's not looking at me. We're thinking of you though, Brecken. You're in our hearts. Whenever we say annoying, just kidding. minute or so to work on these, then we'll go over them together. Go put your pencils down. Even if you're not finished with these, let's see how we did. The first one's kind of insulting because they already isolated the absolute value for you. So we just make two equations, Maddie. And when you move the 5s over as negative 5s, you get x is equal to, and x is equal to. There we go. Really easy, straightforward. How many got those answers on the first one? Good. All right, looking at the next one. Again, what two equations, Kendall?
2y minus 6 equals 10, and 2y minus 6 equals 22.
And first step, of course, is to put a, move over
and 6
as a
positive.
positive 6 on both sides. And of course, that'll give me 2y equals 16. So y equals 8. And then here, that'll give me 2y equals, so therefore y equals negative 2. All right, there are my answers there. How many have those answers? Questions?
I got 2 and negative 8 again.
2, oh.
2 and negative 8.
Positive 2 and negative 8.
Yeah.
Okay, what I think happened, look at your work. Did you put a negative 6 and get negative 16 and, or 4 and negative 16?
Yeah.
Okay, so yeah, make sure when we move it over, when it changes sides, it changes signs. Did you say that a minute ago on one of the problems?
Yep.
Or we had like, I don't remember which problem it was. I didn't hear you say the signs backward. I thought I heard you say the correct signs, just the actual, like it was like 5 and negative 2. I thought you said I had negative 2 and 5, which is the same as 5 and negative 2. But you said you had negative 5 and positive 2. I'm sorry, I did not hear you correctly, which is why I said it was okay. So in case, you know, Gavin is screaming at his computer when I said that, that's not right, Mr. Navigator. Okay, we got it now. We're good. I don't see Gavin screaming at his computer. All right. All right, but does that make sense now? So again, show the step where it changes signs, because if you try to do it in your head, you're like, well, I know it's going to move as a positive 6, so that gives me 4. Again, it's just the power of the brain, which you can see, you tend to act on. What you can't see, you tend to forget. So take the moment to write the +6 so we don't screw up. Coming to Michael, on the next one, we aren't ready to do anything until we've isolated the absolute value, but all we have to do is
divide negative 72 by 6.
There we go. And that'll give us the absolute value of k negative 16 equals.
Let me find that.
I think you might be kidding, but I'm not sure.
Negative 12.
Negative 12 is correct.
I didn't bother because I knew it would be a negative.
And then what?
You can't do it, no solution.
Right, you can't do absolute value. Don't say equals 12 and negative 12. If it says negative, you say no solution. Sounds like a cheer or something. When I say negative, you say no solution. Negative. There we go. Thank you, Abby. Everybody else leave me hanging. Come on. Thank you, Abby. New favorite student. All right. Questions on these first three. Now we come over here. There's a couple weird things happening. First of all, we've got this 1/5 right here. That's kind of annoying. Who remembers from Algebra 1 how we get rid of the 1/5? Favorite student?
Multiplied by 5.
Multiplied by 5. Now Brecken's jealous. He's like, I thought I was favorite. You were, but I couldn't hear you. All right. So we cancel the 5s, and we end up with. Sure.
X plus 28.
Hey, with great privilege comes great responsibility. You got to answer all the questions now, all right? All right. Brandon's my new favorite student. He's just erasing all this work. I'm like, I don't have to know any of this. All right, now there's a couple reasons why, right? One of the things I taught you was if you multiply by the reciprocal, 5 over 1, you knock out the fraction, right? Another way is you could say multiply everything by the LCD. How many remember me emphasizing that? There was a long thing about hating fractions. You remember that now? You don't remember? Algebra 1? I know it was a long time ago. You were young, so young. Now you're a senior citizen. But anyway, so that's another way is we could say, well, this is a thing, and it is all one term, and this is a thing, and we could multiply everything by the LCD, which is 5, and that would also work. Or you could look at, remember we said if you have like a 1/5 x, that means the same as a 1x over 5, or just x over 5, right? So in that sense, we could treat this like an x plus 28's absolute value all over 5. It's divided by 5, so if you multiply by 5, it knocks it out. Several reasons why that works from Algebra 1. Anyway, we're to this point. Now what do we need to do? Genesis?
Make two equations.
Right, what are they?
X plus 28 equals 15x.
And?
X plus 28 equals -15x.
Good. Whatever's inside the absolute value, x plus 28, is equal to both positive and negative, whatever, listen, is on the other side. There's a 15x on the other side, so positive 15x and negative 15x, whatever's on the other side. From here, we solve, and we want to get rid of the little x, Genesis.
The x.
And we move it over as a, well, it is a positive, so we move it over as a negative 1x to get. And so x is going to be equal to 2. You were right the first time. 2. Now, if you're not sure, two things. You can try dividing it, right? Just 28 divided by 14. But if you're not sure it'll come out evenly, instead of saying on your calculator 28 divided by 14, do 28 and then that fraction button, which will do the backwards L looking thing, 14. And if it comes out evenly, it'll just say 2. And if it doesn't come out evenly, it'll make it a fractional answer for you. Okay? For instance, over here, Genesis, which is the little x? The negative 15. So we got to move that over as a positive 15x to get. And for that matter, if the x is coming over here, that means we need to move the number to the other side as a 28. So when we divide this by 16, again, you could probably reduce it on your own, but there's no problem typing in negative 28 fraction 16. And what does it come to? Negative 1 3/4. Now, I wouldn't normally go with a mixed number if I had to do it myself, right? I would divide it, at 4 out of both of them, make it negative 7/4. But if I'm doing it on the calculator, this isn't a wrong answer, right? I'm just normally too lazy to get it. The calculator did it all for me. I'm even lazier. And so there are potentially my two answers, right? Questions getting to this point before we check. Any questions? How many got those two potential answers? Okay, a few of you. Those who didn't, questions. All right, but because there's an X inside and an X outside class, we have to check. So let's go back to the original problem here. So erase all these extra markings that we made. And let's plug these in. Obviously, I want to start with the easy number, class. 2. I like 2. All right, so 2 plus 28, class. 30. What's and the absolute value of 30? 30. What's a fifth of 30?
6.
6. All right. What's 3 times 2?
6.
6. It checks. Get your calculators ready. Negative 1 3/4 plus 28. Gavin, don't show off. 26 1/4. Good. What's the absolute value of 26 1/4, class? 26 1/4. Now multiply the 26 1/4 times 1/5 times 1 fraction 5. 5 1/4? Someone else verify? We all got 5 1/4? I should probably get my calculator out, but I'm lazy. All right, now multiply negative 1 3/4 times 3. Negative 1 3/4 times 3. What do we get?
Negative 5 1/4.
Negative 5 1/4. Are those the same things? No. And by the way, I know that a negative times a positive is going to come out negative, right? But this side has to be positive. So I already know whichever answer was negative was going to be the no solution. And fortunately, it's the uglier of the answers that gets to be the no solution. I'm happy with my x equals 2. How many figured the 2 worked and the other did not? Questions? Let's take a look at this last one here. How do I get rid of this 1/4 so that I can isolate the absolute value, class?
Multiply by 4.
Multiply by 4. Both sides by 4, or you could say everything by 4. However you want to look at it, right? Because the 4 is going to knock this out. I've got the absolute value of x minus 2, but what's on the other side now, class?
8x plus 12.
Good. It's now an 8x plus 12. Everything gets multiplied by the 4. Questions on that first step? All right, now I've got the absolute value isolated. I'm ready to go ahead and make 2 equations. My first equation is set equal to positive whatever. So x minus 2 is equal to positive that. Well, what is, class? Positive that.
8x plus 12.
Yeah, 8x plus 12, that. Careful. I also need to set the x negative 2 equal to negative that. What is negative that, Audrey?
Negative 8x minus 12.
Negative 8x, negative 12. Do you notice how all the signs change? Because it's negative, all of it. Does that make sense? Questions on that step? Now we solve the little x, class. X, move it over as a negative x. Also bring the 12 over as a to get.
Negative 14.
Be careful, don't fall in the trap yet of saying just because it's negative it won't work out. We can't rush to that judgment yet. Here we're going to get x is equal to, but I am suspicious of that answer. Okay, let's go to the other one. The little x is the,
Negative 8x.
bring it over as a
Positive 8x.
positive 8x. Thank you, Brandon, for joining in there. Bring the negative 2 over as a
Positive 2.
positive 2. I just lost Brandon. We combine our x's, class, to get
9x.
good. All of you capable of doing this. Good. And then here we're going to combine the negative 12 and positive 2 to get negative 10. And we end up with x is equal to negative 10 ninths. That answer is also negative. I don't like that either. Okay, well, here we go. Well, let's start with the easy number, shall we? Negative 2. Negative 2, negative 2?
Negative 4.
Negative 4. Absolute value of negative 4. 4. What is 1/4 of 4? 1. What is 2 times negative 2? Negative 4 plus 3? I was suspicious, and I was rightly suspicious. That's extraneous. Calculators. Negative 10 ninths minus 2?
Negative 3 and 1/9.
Negative 3 and 1/9. What's the absolute value of negative 3 and 1/9?
3 and 1/9.
Hit the negative button on your calculator and take the negative sign off. So now we're at 3 and 1/9. What's 1/4 of 3 and 1/9? 1/4 times the 3 and 1/9. 7 ninths? Someone else got the same thing? All right, so we're going with 7 ninths on the left side. All right, 2 times negative 10 ninths. This is why you're allowed to have a calculator in Algebra 2, by the way. All right, what do we got? Negative 2 and 2 ninths plus 3. Oh, it's weird looking and it's negative, but it checked out. There's my solution. Did anyone happen to get negative 10 ninths for the answer? Wow, great job. Okay. But that's not why she's favorite students, because she cheered with me. All right, questions on this. Do you see how the calculator is your friend and why I break down and let you use one in Algebra 2? The calculator is not your friend? You're like, I'm faster in my head, Mr. Tedeschi.
No, it's not working.
It's not working.
Well, it is. I just don't know how to do mixed numbers.
Oh, don't know how to do mixed numbers. Okay, so we watch. Okay, in fact, this might help. This might help Gavin and Brecken too. So let me see right about here. You should be able to see just fine. So I'm going to kind of hold it here for Brandon's benefit, but everyone's benefit. So let's say we're plugging in the negative 10 ninths, right? So we'll do 10 fraction 9. You see what that looks like? Okay, we're going to do 10 fraction 9, and then I'm going to hit this little negative button down here to make it a negative 10 ninths. I think Maddie and Michael are going to have to hit the negative first. Okay, I think your calculator said do the negative 10 ninths first, maybe, maybe not. Okay, so we got negative 10 ninths on the calculator. Again, the negative just sticks on the front. We're going to do minus 2, so minus 2 equals. And now it says negative 3 and 1/9. Okay, and then we need to take the absolute value, which of course is just going to take the negative off. So when I hit the negative button, it takes the negative off. And then I need to multiply that by 1/4. So we do times 1 fraction 4 equals. And that's where we got the 7/9. Make sense? Then on the other side, we take the 10 fraction 9 negative to get negative 10/9 times the 2 equals to get negative 2 and 2/9. It says plus 3 equals, and there's the 7/9. Okay, hopefully that was a help to you guys. Was that a help to you? All right, anyone else trouble with the calculator? No, Maddie and Michael, your calculators are not the same as everyone else's.
Michael's the same.
No, it's not. He went with a Casio. Abomination. I know, the look on your face. It's the look on my face, mentally.
I'm not used to this because I use one of those.
What?
I have one of those at home.
Oh, trash. All right, questions on this? All right, we'll practice more with this tomorrow. You'll practice a little bit with this in your homework, though, this evening. Page 76. Page 76. I want you to do the review, 7 through 12. Page 76, the review, 7 through 12. And on page 82, do the review, 1 through 6. And on page 82, do the review, 1 through 6. So page 76, review 7 through 12. Page 82, review 1 through 6. Tomorrow we're going to wrap up this concept and begin our exam review. Monday we will be reviewing all hour for the exam, which will be on Tuesday in lesson 44. Have a wonderful rest of your day. When the bell rings, you will be dismissed.